All right. Ugh. Hello, class. I'm here with Bugs, and we're going to do another paper one. So, actually, I'm just going to put it back here. Good boy. So, if you haven't caught on, paper one is, you know what I wanted to tell you guys is today I ran to Miss Tran's house. So I don't know if any of you guys have Miss Tran, but she's an IB teacher, and I ran out to her house. I said hello to her. I saw her dog. She has a dog named Baby, and Baby's a pretty nice dog. So let's see. Let's just get into it. So this is paper 2. This is from time zone 2. So that means that it would be the same as it would have been given to students in the Americas. You can see M19. M19 means that it's May 2019 is the year. So I'm doing 2019 May, time zone 2. And today I'm going to be working out the even problems. Yesterday I did the odds, and today I'll be working out the evens. So if you have any questions, ask it in the live chat and I'll be happy to answer them. Okay, so you can see question 1 is once again about, oh my gosh, I don't know if you guys can hear that. I have a guest cat in the house right now. His name's Ivan, and he's making a lot of noise. So let me see if I can capture it. See if I can capture Ivan. I captured him. I know. Oh gosh. This is Ivan. Oh, I just got hissed at. Did you see that? Come here. Come here. He's a mean cat. Okay. So where are we? We're on number 2. What is the unit of electrical potential difference expressed in SI units? So, electric potential difference. So we just got to think of an electric potential difference. That's another word for voltage. So we got to think of an equation with voltage in it. And the one that I can think of is P equals IV. Power equals current times voltage. Okay? Now, there's this concept of a fundamental SI unit. So the fundamental SI units are sort of the basic quantities. So the fundamental SI units are kilograms, seconds, Kelvin, meter, amp. So not coulomb, but amp is a fundamental SI unit. You express all the So we need to express all these quantities in terms of their fundamental SI units. Power is measured in watts. Current is measured in amps. And then we have units of volts. Okay? So we already have amps. That's an SI unit. We already have amps, which is an SI unit. And now we got to express watts in terms of fundamental SI units. Well, you might remember that watts are joules per second. So we have joules per second equals amps times units of voltage. But then joule isn't a fundamental SI unit. So we got to express joules in terms of that. Well, remember how joules is energy. And energy is, one form of energy is kinetic energy, which is kilograms meters squared per second squared. So that's mv squared, 1/2 mv squared, right? So we have that divided by seconds equals A times units of potential difference. And then we just got to solve for that. So we got kilograms meters squared, seconds to the -3, amps to the -1. So that would be C. All right. That's kind of a tough one, I thought. But I will say that the IB exam does have, I don't know why, but they're sort of obsessed with this idea of fundamental SI units. I don't think it's that important, but they do. Okay. Question 4. I think I'm back. So the maximum, sorry guys, my internet is actually really volatile today for some reason. So the maximum force we can get is if these two forces point in the same direction. So that would be 12 plus 24 equals 36 newtons. That's the maximum. The minimum force we could get would be if they point in opposite directions. So if they point in opposite directions, we would get 12 newtons. And we could actually get anything in between. Okay, so I think I'm back, hopefully. Nope, I'm not back. All right, I think I'm back. Hopefully I'm not going to have any more issues. So, anyways, if the two forces point in the same direction, it's 36 newtons. If they point in opposite directions, it's 12 newtons. If they are perpendicular to each other or at some angle, you'll get something between 36 and 12, which would be 10 newtons, which would not include 10 newtons. So the answer is A. Question 6. A boat with an output engine power of 15 kilowatts moves through the water at a speed of blah. What is the resistive force acting on the boat? So here we're using an equation for power. It's power equals force times velocity. Okay, and the power is 15,000. The velocity is 10, so that means that the force is 1,500 newtons, which is 1.5 kilonewtons. So the answer would be C. Question 8. Question 8 says a table tennis ball of mass 3 grams is fired with a speed of 10 meters per second from a stationary toy gun of mass blah. The gun and the ball are an isolated system. What are the recoil speed of the toy gun and the total momentum of the system immediately after the gun is fired? So the two start at rest. So that means there's an initial momentum of 0. And they end at rest, so that means, the momentum is conserved. So afterwards, the momentum has to stay 0 because it was 0 before. So the answer has to be A or C. And to figure out the recoil speed, we'll use conservation of momentum. So we have, basically we're going to have 0 equals momentum of the ball, which would be 3 times 10, plus the momentum of the toy gun, which would be 0.6 times V final. So we can get, so that says that V final equals negative 30 over 0.6. So that's 300 over 6, which is oh, you know where I messed up? Is see how that says 3 grams and this says 0.6 kilograms? So I gotta retype this out. So 3 grams would be 0.003 and 0.6 kilograms would be 0.6. So what we'll have is 0.03 divided by 0.6. So that would be 0.05, which is A. All right. So I hope that made sense. Number 10. Substance changes from solid phase to the gas phase without becoming a liquid and without a change in temperature. What is true about the internal energy of the substance and the total intermolecular potential energy when this occurs? So the thing you have to know is that just like when you get further away from the Earth, your gravitational potential energy increases. Okay? And if we think about going from solid to gas, the atoms are getting further apart. So that means there's an increase in potential energy. Okay? So the total intermolecular potential energy of the substance is going to increase. Internal energy includes the internal kinetic energy and the internal potential energy, okay, of the material. And so the fact that there's no change in temperature means that the kinetic energy part stayed the same, okay? But the potential energy went up. So their sum had to increase. So the internal energy also increases. The answer would be C. All right. Number 12. A container holds 20 grams of argon-40 and 40 grams of neon-20. What is the ratio of number of atoms of argon-40 to neon-20? So the argon-40 is twice a single atom of argon-40 is twice as heavy as neon-20 because it has twice as many nucleons. Okay? So 20 grams of argon-40 would have half as many atoms. I don't want to get this backwards. Let me try this out. These kind of problems, sometimes they get it backwards. So the number of atoms of argon would be 20 grams, and then each one is 40. So 20 over how many there are. For the neon, we've got 40 grams, and each one has a weight of 20, so that would be the number of neon. Oops. So this would be the number of neon. All right. Really sorry, guys. I don't know what the deal is with my router. I'm watching my router, and you know how it has like a certain color when it's connected to the internet, and the color it's giving me keeps changing. So the number of argon divided by the number of neon is going to be, well, there's 20 grams at 40 grams per atom. All right, I'm back with number 12, which has been a 10-minute problem. So the number of atoms of argon, divided by the number of atoms of neon is going to be this, which is going to equal 1/2 squared, which is going to equal 0.25. Okay. So the answer would be A. So my logic for this is that if you had 40 grams of argon, you would have half as many argon atoms, because the argon atoms are twice as heavy. Okay, so if you have the same weight, you only have half as many atoms, and then you have half the amount of argon, so you have half of the half, which is 0.25. All right, going on to number 14. Object P moves vertically with simple harmonic motion. Object Q moves in a vertical circle with uniform speed. P and Q have the same period t. When P is at the top of its motion, Q is at the bottom of its motion. What is the interval between successive times when the acceleration of P is equal and opposite to the acceleration of Q? So basically, they're going to be equal and opposite when they're at the top and at the bottom. So that's half a period apart, so I would say the answer is B. The answer is B, period over 2. Now, why do I say that? They can't be equal. So the accelerations can't be equal and opposite when Q isn't at the top or the bottom. And the reason for that is if, like, let's say Q is right here, then the acceleration points towards the center of the circle, which can't be opposite the acceleration of this mass, the mass P, because mass P's acceleration is always pointing up or down. Okay? So it has to be when it's at the bottom and at the top, and there's half a period between being at the bottom and being at the top. So I would say the answer is B. All right. C, monochromatic light is traveling upwards in glass and is incident on a boundary with air. The path of the refracted light is shown. So we can see this is total internal reflection. This is what is happening. Whoop. A layer of liquid is then placed on the glass without changing the angle of incidence on the glass. What is the path of the refracted light? The answer is going to be D. Now, why do I say that the answer is D? Well, Snell's law says that N1 sine of theta 1 equals N2 sine of theta 2. All right? But if we add another interface, we would have N2 sine theta 2 equals N3 sine of theta 3. So see how all three of these have to be equal to each other. So basically what happens is if you put a layer in between, you're still going to have the same angles, okay? Because we basically just added another thing that's equal in the middle. Okay, so it's going to do nothing. The answer is D. Number 18, a particle with charge Ne is accelerated through a potential difference V. What is the magnitude of the work done on the particle? So I would say power equals IV. Power is work done per time. Current is charge per time. All right, so you can see the 1 over times cancel each other out, and we get work equals Q times V. And then, so that means that work equals Ne times V. All right, so the answer would be B. Number 22, or 20, 3 resistors are connected as shown. The voltmeter is ideal and the cell has an EMF of 12 volts with negligible internal resistance. What is the reading on the voltmeter? So the voltmeter is actually reading what we would call the terminal resistance. Okay? Because we can see we have basically a real battery. Okay? We have a real battery with EMF 12 and internal resistance of 1. Okay? And then we're seeing how much voltage does the external circuit get. So let me type this out. The current, so V equals IR. The voltage is 12 volts. The current is I. And then the total resistance is 4 ohms, which I will assume that you can calculate. It's 6 in parallel with 6, in series with 1. So that gives a current of 3 amps. And that 3 amps is fed into the external resistors. The external resistors have a total resistance of 3 ohms. Okay, so I have I times R external. So I have that equals 3 times the external resistance, which is 3. So I get 9 volts. So the answer would be D. 22. A particle of mass 0.02 kilograms moves in a horizontal circle. So the direction of the force is towards the center of the circle. Okay, so the answer has to be B or D because it's a centripetal force. The force points to the center. Now let's figure out the size. Well, one of the things I taught you is that the angular velocity omega is 2 pi over the period. So that says that 3 pi equals 2 pi over t, which says, I'm going to do this a different way. I take it back. I taught you that V equals omega r. So that means that V equals 3 pi times r. So that means the velocity is 3 pi. Okay? Then that means the acceleration is V squared over r. So that would be an acceleration of 9 pi squared over 1. And then F equals ma. So that means that the force is equal to 0.02 times 9 times pi squared, which would be did I goof? Where did I goof? I'm wondering if that's a typo. Well, that's what I get as the force. So I don't know why. I'm going to look up, note to self, look up number 22. I think that might be a typo on their part because I'm getting that the answer is F equals 0.18 pi squared. So that I don't even see that as an option. So I think none of them are correct, but maybe I'm wrong. 24, a radioactive nucleus. Nuclide with atomic number Z undergoes the process of beta plus decay. What is the atomic number of the nuclide produced, and what is another particle emitted during the decay? So we emitted a positive particle, and charge has to be conserved. So the nucleus has to lose a unit of charge. So that means that the answer has to be A or C. And we have to have conservation of lepton number. So a beta plus is an anti-lepton. So anytime you have beta decay, you're going to get either a neutrino or an antineutrino. And beta plus is emitting an anti-electron, which has a lepton number of -1. So the other particle needs to have a lepton number of +1, and it is the neutrino that has a lepton number of +1. So the answer is A. 25 says the positions of stable nuclei. Oh, I'm not doing 25. The 3 conservation laws in nuclear reactions are conservation of charge, baryon number, and lepton number. Which conservation laws are violated in the proposed reaction? So, again, we have, oh my gosh, like almost everything is violated here. If we look at the lepton number of a neutron is 0. So let's look at it in terms of lepton number. The reactant has a lepton number of 0, and the product, well, the pi minus, I should say what a pi minus is. That's equal to a, it's a, why am I blanking on what it is? It's a down quark and an anti-up quark. So, yeah. So it has a charge of -1, and it has a lepton number of 0 because it's made out of quarks. So the products have a lepton number of 0 for the pi minus, -1 for the anti-electron, and then -1 for the anti-electron neutrino. So Lepton number is violated because we have 0 goes into -2. Looking at baryon number. The baryon number of a neutron, it's made out of 3 quarks, so it's 1/3 plus 1/3 plus 1/3 equals 1. And then a pion has a baryon number of 0 because it's a baryon and an antibaryon. And then the other two things are leptons, so they have a baryon number of 0. So we have 1 goes to 0. So baryon number is conserved, is not conserved. Charge, charge, we have an initial charge of 0 because it's a neutron. And then we have a final charge of 0 because a pi minus has a charge of -1. A anti-electron has a charge of +1, which combines to make 0. And the neutrino has no charge. So anyways, so that means that 2 and 3 are violated. So the answer is C. B, a neutron collides head-on with a stationary atom in the moderator of a nuclear power station. The kinetic energy of the neutron changes as a result. There is also a change in the probability that this neutron can cause nuclear fission. I think I forgot to talk to you guys about this, but so let me type it out. Moderators slow down neutrons. They slow down the neutrons emitted in radioactive decay, which makes them more likely to create or to cause other radioactive nuclei to decay. All right, so basically the neutrinos, we slow them down because once we slow them down, they're more likely to bump into other stuff. Okay, so the change in kinetic energy, the kinetic energy of the neutron is going to decrease as a result of the moderator, but their probability of causing a fission is going to increase. So the answer would be B. 30, the orbital radius of the Earth is about 1.5 times that of Venus. What is the intensity of solar radiation at the orbital radius of Venus? So one of the things I told you is that the solar constant above the surface of the Earth is 1,400 watts per meter squared. So that could be written as 1.4 kilowatts per meter squared. All right? And it depends as 1 over r squared. Okay? So we're basically, if we're at the orbital radius of Venus, the r is now 2/3 what it was for Earth. So we want to divide by 2/3 squared. So 1.4 divided by 2/3 squared, because it's an inverse square law. So that would be times 9/4. So it's going to almost double it, or more than double it. So the answer would have to be 3 kilowatts per meter squared, D. All right. So I apologize that that took a really long time. If you stuck with me, thanks. You're a champ. One thing I wanted to say is that your work for these problems, you are going to submit them, and it's going to be next week's quiz. So next week's quiz is going to be just to turn in your work for this week's daily items. Okay? So that's all I have for today. Have a nice day.